All right, all right, all right. We got the last page here. We got problems number 33 and 34. Praise the Lord. We're almost finished. So let's see here, problem number 33. We see this is the most hated topic in organic chemistry, NMR spectroscopy. It almost sounds like a dirty word, but here we have our principle here is to count the peaks. 1, 2, 3, 4. When we use this method, a lot of times we can eliminate the choices here just by looking at the number of signals. So here, this is one where we have all these constitutional isomers with the same molecular formula. No molecular formula is given, but you can see it here in the number of carbons and hydrogens, etc. This one here we can eliminate because we have only 3 peaks. On A, we could not eliminate that. On C here, can't eliminate that one because that one could possibly have 4 peaks. And on D, we also have 4 peaks. So unfortunately, we have to refer to the chemical shift. We don't have integration on this one, but we're going to refer to chemical shift, and we can also at this point refer to our splitting patterns too. But here we see we've got 4 ppm. That's something attached to an oxygen. So it's either this one, or this one. All right, so all of these have oxygens. That doesn't give away the answer. We have to refer to the splitting pattern, but we don't have to look at too much splitting with this one, I don't believe. So we have a triplet here. And so that means that that is something by a CH2. This is a CH2 right here, where N is 2. And so let's see here. On A here, A would be the one giving off the signal here at position number 2, and that is indeed by a CH2 right here. There are 2 hydrogens right here. Okay. This one here, that carbon is not by a CH2, it's by 2 CH3s. I only have to draw one of them to really illustrate that is not a CH2 right there. Why did I even look at that? I'm getting really tired. Let's look at this one down here. This is only a CH3 by nothing. Right here, that's going to be a singlet. There's no way it can be that one. And let's look at 3 here. What I have labeled 3. This one here is also by a CH3 over here. So we actually eliminated D on that one just looking at the splitting pattern. Now splitting is more complicated. It's always complicated that N refers to what is beside it, not what is directly attached. So it was these 2 hydrogens beside another 2 hydrogens here giving off the signal. And so because we had 2 hydrogens, 1, 2 right here, that will be a triplet. Okay, so A is the answer on that. This one right here is by, I'll go ahead and do the splitting on that one. It's by 1, 2, 3, 4, 5 hydrogens right in here. So that should appear as a sextet. 1, 2, 3, 4, 5, 6. That's that one right here. And it's fairly far away from the carbonyl and the oxygen, so it's going to appear at 1 something. The singlet that appeared right here, that's this one, the acetate methyl group. Those 3 hydrogens right in there is going to give off that singlet. And then we have another triplet over here. That's below 1 in that case. That's these 3 hydrogens that are beside 2 hydrogens. Okay, last one. Let's see. So again, we refer to the number of peaks, 1, 2, 3, and we go through 1, 2, all these methyl groups are the same, so that's 3. 1, 2, 1, and then we have 3, 4, 4. Oop, and I forgot about this little one, 5 right there. So we got too many peaks with that one, or too many potential signals with that one. That can't be it. Here we have 1 and 2, 3. This is by a stereogenic center, so it is actually potentially 4, 5, 6 peaks with that one. Can't be C. Okay, watch out for D. D has a lot of symmetry. Here we have 1, 2, and these are equivalent 3 peaks on that one. So that one may be a possibility. Let's look at these integration now though. So here we do have the number of peaks, and we can go to integration. This is integration when you see it. Two hydrogens rather means this is probably going to be a CH2, though it can mean other things too. The 9H is very distinctive. When you see that, usually you have a tert-butyl group. That bad boy right there. Tert-butyl group. 9H on that one for a tert-butyl group. This one here though, it was confusing enough. We got all these methyl groups all over. The only equivalent ones though are these and these right here, because that symmetry of the molecule, this would have appeared as 6H for those right there. So another reason that D is wrong right here. Okay, so 9H, there's that bad boy right there. Here we have a CH2 right here and another CH3 here at the end. That's that one right there. Usually when you see an ethyl group, you got a quartet and a triplet and a quartet. All right, good luck to you guys. I'll see you tomorrow.